Now we're going to do page 370, number 10. Judy and her friend Helen live on opposite sides of a river that is 1 kilometer wide. Helen lives 2 kilometers downstream from Judy on the opposite side of the river. Judy can swim at a rate of 3 kilometers per hour. The river's current has a speed of 4 kilometers per hour. Judy swims from her cottage directly across the river. What is Judy's resultant velocity? Is part A. Okay. So here's a diagram. Judy swims directly across the river. That's where she's heading. So that's the swimming vector. The current vector is heading down the river. The resultant is going to head this way at some angle that we need to find out. Okay, so they want the resultant velocity, so we need to find the magnitude of r. Because it's a right triangle, we can just use Pythagorean theorem. Magnitude of s is 3, the magnitude of c is 4. Plug it in, square root it, you get 5 kilometers per hour. So that is the resultant speed of Judy's swimming. The angles, well, if we find theta, then we can subtract it from 90 to get alpha, the angle from the bank. Well, tan theta equals opposite over adjacent. So 4 over 3, which means that theta is 53.1 degrees. Subtract that from 90, you get alpha equal to 36.9 degrees. Okay, so therefore Judy's resultant velocity is 5 kilometers per hour at 36.9 degrees to the bank heading downstream. Okay, so to the bank heading downstream is the direction. Okay, so we're going to do part B. Part B says, how far away from Helen's cottage will Judy be when she reaches the other side? So we look at this diagram. The width of the river is 1 kilometer. The distance downriver to Helen's is 2 kilometers. So there's Judy, there's Helen. She's going to head at 53.1 degrees from this way. We calculated in the last part. And we're going to figure out what x is. Okay, so fairly straightforward. Tan 53.1 is x over 1. Okay, it's a right triangle. And x equals 1.33 kilometers. Okay, y then is the distance away from Helen, so I'm going to subtract the x from the 2, and I get 0.67 kilometers. Therefore, Judy will end up 0.67 kilometers from Helen's. Okay, the last question in this one, part C, how long will it take Judy to reach the other side? Well, in order to do that, we need to find out how far Judy has to swim. We know her speed along this diagonal here, but how far is that? So we plug that in. Okay, we get cos of 53.1 equals 1 over z. 1 over z. So adjacent over hypotenuse. Work that out, and you get 1.67 kilometers is the distance that she would have to, they'd end up traveling through the river. Okay. Now we have the distance, we have the speed, which is 5 kilometers per hour. Plug that into our formula for time. Time equals distance over speed. So 1.67 kilometers divided by 5 kilometers per hour, and you get 0.333 hours, which works out to approximately 20 minutes. And therefore it'll take Judy about 20 minutes to reach the other side of the river. And that's it for that one.